So here's a recording on the Chapter 8 and Chapter 9 review problems. I actually think that I'm like recognizing a lot of these problems. I think that we've done them, a lot of them, other places, but we'll get going on them. Anyway, they say that the variables represent positive numbers. That means I don't have to worry about absolute value. So this is just the square root of 81 is 9, the square root of x squared is x. Cube root of 64 is 4, and then you can divide the index, right? 9 divided by 3 is x to the third. 6 divided by 3 is 2. And here, so I'm going to have to make a good pile, bad pile. I have this paper just in case I can't fit it in the spot. And so I'm not saying that I'll be able to do all of them. 200 is 2 times 100. And I kind of recognize 100 as a perfect square. And x to the fourth is a perfect square times x. And then y to the 18th is a perfect square. Now you could go ahead and prime factor that all the way down if you wanted. 100 is 2 times 2 times 5 times 5. But the square root of 100 is 10. And if you think of that 2 times 2 times 5 times 5, and you start circling them in groups of 2, a 2 comes out and a 5 comes out, so 10 comes out, right? And the square root of 100 is 10. So however you do it is great. This is, if you circle them in groups of 2, if you wrote them all out and circle them in groups of 2, you're going to get 2 x's out, so x to the second. And you're going to get, writing them all out and circling groups of 2, 9 y's, right? 18 divided by 2 is 9. Still stuck underneath the square root is a 2 and an x. And so there's our answer there. This is the fifth root of 32. Well, now 32 is a perfect fifth because 32 is 2 times 2 times 2 times 2 times 2, 5 times. That's a perfect fifth. That's a perfect fifth. So this is just perfect. This is 2. Divide, so you get 2, x to the second. Divide, and you get 5, right? Y to the fifth. The problem here is I have the square root of a fraction, which isn't allowed. So I would write this as the square root of 2x over the square root of 3. And then the problem is I have a square root in the denominator, which is not allowed. So I would match it. It takes 2 for it to come out. So because it's a square root, so now I've made 2 3's underneath there. Or another way of saying it, I've made the square root of 9 in the denominator, which is equal to 3, right? For every 2 that are the same, 1 comes out. Or you could say that's 9. Now what you do to the numerator, you got to do to the, what you do to the denominator, you got to do the numerator. So that's 2x times 3 is 6x. And that doesn't reduce, so this is 3 and then the square root of 6x on the numerator there. So square root of 6x over 3. And I kind of remember this one. Am I right? Am I right on that? So here I have square roots in the denominator, so, and it's a binomial, so I have to multiply by the conjugate. So I hope that this will fit here, or maybe it won't, but here's the conjugate. And what you do to the numerator, you do to the denominator and vice versa. So in this case, I'm doing that to the denominator. And so when I multiply here, I just want to use FOIL. And the outer and the inner are going to make 0. So I'm just going to do the square root of x times the square root of x, which is x. And then minus, and then the square root of 3 times the square root of 3 is 3. Then I have the square root of 3 times the square root of x is the square root of 3x. And the square root of 3 times the square root of 3 is 3. So minus 3. And then that's all I can do here. And what's made it different is there's no square root in the denominator, and that's considered unsimplified, have square root in the denominator. I know for sure we had this one. I helped a lot of people do this one. The fourth root of 16 is 2. And the fourth root of x plus 8 to the fourth, 4 divided by 4 is 1, is x plus 8. To the first, which it wouldn't be required to write a 1 there. And this is good, or you could write 2x plus 16. That's good too. Okay, the square root of 49 is a perfect square. That's a perfect square. That's a perfect square. So that's all perfect. So this is 7, a to the second, b to the fifth. Then I have a cube root of 8, which is 2. This is a perfect cube, and that's a perfect cube, so you divide a to the third, b to the fourth. And then 7 and 2 don't reduce. A to the second and a to the third, if you imagine writing them out, would leave an a in the denominator and a b in the numerator. And so that's it on that one. So there's our answer here. Either one here. Not very accurate on circling them. Maybe I should stop circling them. I'm not doing that good of a job. I have the two screens to look at is why. Okay, the fourth root of 48. This one maybe is going to take me more room. So I'm going to write number 9 here. So I have the fourth root of 48. Now 48 is 2 times 2 times 2 times 2 times 3. And a to the 11th, a. I don't normally write them all out, and I don't know why I have written them out here. I guess I just got crazy. And so you don't have to write them out. I'm going to write the C's out just because I wrote the numerator out. And 1, 2, 3, 4, 5, 6, 7, 8. And so circling these things in groups of 4, a 2 is going to come out. And circling in groups of 4, an A is going to come out. And another A is going to come out. Oh, shoot. Oh, shoot. Sorry. I prime factored all of that. And I wrote all those A's out. There was 11 of them. And the C's all out. There were 8 of them. And then now I'm circling them in groups of 4, right? And there's 3 A's left under. So in the numerator, I have the fourth root, a 3 stuck, and 3 A's stuck. And in the denominator, a C comes out and another C comes out. And no C's are stuck underneath. And so when I clean this up, this is 2a squared times the fourth root of 3a cubed over c squared. Sorry about that. Got writing off my paper. So this is the third root, and maybe I need to write 10 here as well. Good news is I've already prime factored 48. It's 2 times 2 times 2 times 2 times 3. X to the 9. And you can certainly write them out, but you can also plan like I was before. Oh man, 10 of them, really? So there's 2, 3, 3 more, 3 more, 10 of them, right? Okay, so circling them in groups of 3. A 2 is going to come out, not going to come out, not going to come out. An X is going to come out, another X is going to come out, and another X is going to come out, leaving no X's underneath. On Y's, a Y is going to come out, another Y, and another Y, so 2 Y's more than I had, so 3 altogether, 1, 2, 3 of them, and a Y stuck underneath. So underneath the cube root, I'm going to have a 2, a 3, no X's, but a Y. So long story short, that's 2x to the third, y to the third, times the cube root of 6y. Okay. Number 11, I might be able to do number 11 right there in the spot. And so number 11, I have the cube root of 2yy and a 4 in the top. And my goal is not to have any cube root in the bottom. That's what I'm not allowed to have. And it takes 3 of them. So 3 of each factor. So I want to multiply by this by the cube root of 2 times 2 so that I have 1, 2, 3 2's. I already have 2 y's, so I just need a y. And what you do to the bottom, you got to do to the top. So the cube root of 2 times 2 times y. So when I put these together, that makes 3 2's underneath there. So a 2 just comes out. And 3 y's. So a y just comes out. And in the numerator, I have 4, and then the cube root of 4y. And then this 2 and that 4 can reduce with one another and give 2. I wish I wouldn't have tried to write it here. It's not going to fit. So can I put it here? 2 and then the cube root of 4y over y. The 4 and the 2 reduce with one another. Okay, so this goes here, right? This one I can fit for sure because this is the square root of 2 over the square root of 5. I wasn't trying to leave enough room on here. I should have just wrote on my paper all of the problems on the paper, but I was like, oh, then it'll make it easier if I write them here. And then I noticed that I'm having to jam my work. So I'm matching that 5, right? The square root of 5 times the square root of 5 is the square root of 25, which is 5, and then the square root of 10. And what makes it no radicals allowed underneath a fraction, so the radical of a fraction not allowed, and then I had the radical divided by a radical, no radicals in the denominator. I'm not going to attempt to write that one here just because that one is there, although I think I probably can fit it. But I'm going to put 13 on my paper here, and yeah, I'm going to move my paper up as soon as I get it written down. So this is the square root of 3x over the square root of 2y, because I'm not allowed to have a fraction underneath a radical. Now I have a radical in the denominator, and I'm not allowed to have that. So it's a square root, so I just need 2 of each. So I'm going to multiply by 2my, and also in the top, the square root of 2y. I'm just matching. So here, when I put these together, I get a 2 out and a y out. And up here, I get the square root of 6xy. So that's number 13. Then number 14. And so we have 40, and then we have the cube root of 60xy cubed over negative 2, and then the cube root of 10x. So this 2 and that 4 will reduce with one another, or I could wait to reduce them. And I noticed that, well, these are underneath a cube root, and the 6 and the 10 will reduce with one another, and the x will reduce with one another. So I'm actually not going to wait. I'm going to actually do that. So this is what I'm thinking, is I'm reducing, I wanted to make this one root like this. Cube root. And this is 60xy to the third over 10x. So this is negative 2. This is the cube root of 6. The x's drop out. 60 divided by 10 is 6. The x's drop out, and then y to the third. And then the only thing that I could do is the cube root of y to the third. There's 3 of them, right? So a y would come out. So this is negative 2y, and then the cube root of 6. 6 is 2 times 3. There's no repeats. Okay, so we did a lovely job on those. So this is 15, 16, 17. I think I can actually write those here. So using this property, where can I write my property? Using this property, that b to the m divided by, it's the other way. I'm going to write the property on this paper right here. This property, b to the m divided by n, is equal to this, right? It's also equal to this. Okay, and this is what I have right here, and I want to write it like that. So this is x to the 2 divided by 4, right? Just using that property, right? Just following what we have here. M is the 4 and 2 is the n, right? So 2 over 4. N over m. I've written this wrong. And that will make this wrong. I wrote my property wrong. This would be the nth root of, is that what I had? No, I don't think it is what I had. And this will be this. I did do it right over here. It's 2 divided by 4, m divided by n. I don't know why. And 2 divided by 4 is half. So this is x to the half. And that's a good answer. Or you could write it as the square root of x. Remember, that's what x to the half is. That's using this property here as well, right? You have an exponent of 1 on the x, and the index is 2, right? 2 in here, which you don't write the 2. So anyway, so that's that one. We did a good job on that. So here I have the square root of x, which is the same as x to the half, times, and then this is x to the 2/3. And then you can, because they have the same base, you can add the exponents, so half plus 2/3. And it's okay to use a calculator to do half plus 2/3, or you could do that with your head, your choice. So half plus 2/3 is 7/6. So x to the 7/6. And I think that's how they wrote it in your book, quite frankly. And so I'm just going to leave it like that. And this is x to the 5/2. Remember, the index here is 2. And this has a 1 there, right? So this is x to the 1/3. And you would subtract those. So 5 divided by 2, 5/2, take away 1/3 is x to the, so I did 5/2, and then I did subtract 1/3, and I got 13/6. So 13/6, and I think they just left that like that in your book. So this is a 1 here. So this is x to the 1/4 times x to the 1/2. When I add those together, x to the 1/4 plus 1/2, you can do your calculator, is 3/4. And I think they just wrote it just like that in your book. And so, so you can write it like that. This one here, because it's a proper fraction, where these are improper fractions, if you wanted to, you could write it with a root. This would be the 4th root of x to the 3rd. They're equivalent to one another, so I'll say or this. Here, I would be tempted, but usually you wouldn't write this as the 6th root of x to the 7th, right? Because there's 6 of them, so 1 would come out and leave 1 under. So this would be x and the 6th root of x. So you could certainly write it like that. So this would definitely be an or if you liked. And the same here, this would be the 6th root of x to the 13. And if you grouped them in groups of 12, or groups them in groups of 2, 12 of them would come out. So it would be x to the 2nd out, and 1 x stuck underneath the 6th root. And so that's also a good. So these are the same as one another. And I think this is what they have in the back of the book. This is a problem in your textbook. 19's not going to fit. And so I'm going to have to go on my paper here to do number 19. How can I get both of them showing at the same time? Here's 19. Okay, so it's a cube root. If it wasn't a cube root, then you can't have a square root of a negative, but it's a cube root. And I know that the cube root of a negative is equal to a negative. So when I start looking at this, I have 5x, and then I have the cube root of negative, which I know is a negative, and 4 is 2 times x. So nothing's going to come out from underneath there, right, except for the negative. And so this negative can come right out. And so this is negative 5x, the cube root of 4x. That didn't come out. And then what did I have? I had plus, and then I have a 2, and then I have the cube root of 256. Now, 256 is 2 times 128. Is that right? Oh, calculator. You got a calculator, friend. 256 divided by 2 is 128, yeah. And this is 2 times 64. And I recognize that 64 is 4 times 16, which is 4 times 4. So you don't have to prime factor it. I'm looking for matches, right? And so 2 times 2 times 4 times 4 times 4. There's 3 matches. That's why I got those. And then XXX, 4 of them. Now, you would get the same thing if you prime factor it all the way. Circling in groups of 2, those are groups of 3 rather. I'm going to have a 4 come out. I already have a 2 out there, so it's going to multiply. And I'm going to have an X come out, and it's going to multiply. And stuck underneath, I'm going to have the cube root of 4x. And that's convenient because that's this guy, right? So this is minus 5x, the cube root of 4x. This is my like term part. That's my number coefficient part, right? This is my variable part. Plus 8x cube root of 4x. There's my variable part. Here's my number part. If your variable parts are the same, you can add the number parts together. Negative 5 and 8 are 3. So this is 3x, and then attach the same variable part. So we did a good job on 19. Boy, 19 was a grand finale kind of problem. Maybe it wasn't that bad. I think I can do 20 in the spot. I'm breaking lead. I think I'm having stress. So the square root of x times the square root of x is x. This is FOIL, except for the outer and the inner make 0. And then, oh, no, it doesn't. That's not a, sorry. That looked like a 4 to me, and it is not. I'm going to have to FOIL this all the way out. So the square root of x times the square root of x is x. Maybe I'll write that on my paper over here. Here's 20. So this is x. This is minus 4 square root of x. And the inner here, plus 7 square root of x, minus 28. Those are like terms. So we get plus 3 square root of x minus 28. So that's number 20. 21 I don't need to put on this paper because this is coefficient 1 here, and they're both square roots of 3. So this is 9 square roots of 3. 10 take away 1. That's nice. 22 there is going to be some simplifying up for me to do. And so here we'll do 22. And so this is 2, and then the square root of 75. 75 is 3 times 5 times 5. And minus 5 times, and 108. What is 108? 108 is 2 times 54, and 54 divided by 2 is 2 times 27. 27 is 3 times 3 times 3. So when I circle in groups of 2, a 5 is going to come out, and it will multiply with the 2 that's already out there. So this is 10 square roots of 3. And then a 2 will come out, and it will multiply with the 5 that's already out there. And a 3 will come out and multiply with the 2 and the 5 that's already out there, and then the square root of 3. So this is 10, that's 30, so minus 30 square root of 3. And then these are the like radical part, so 10 take away 30 is negative 20 square roots of 3. So that's 22. 23 is 2 square roots of x minus 7 quantity squared. So you need to write this twice and FOIL. 2 square roots of x minus 7. And so when I FOIL this together, I'm going to get 4 square root of x times square root of x is x. And then 2 times 7 is 14 minus 14 square root of 7. And in here, we're going to get another 14 square root of 7, square root of x, sorry, I don't know where that came from, and then plus 49. So there's 28 of those. So 4x minus 28, square root of x, plus 49. And then 23, oh, that was 23. Now we're looking at 24. I know that I've done 24 with a number of people with the different number that they have. And I put the 6 there because I was going to say I saw one with 6, a whole bunch. So in order to add these together, you have to have like denominator. The denominator's 5 here, and I think to myself, if I rationalize the denominator, this denominator would be 5. So I'm going to rationalize this, multiply by the square root of 5 times the square root of 5. So I did nothing here. And I get here, when I multiply those together, 5 square roots of 5. And then when I multiply these together, I get the square root of 25, which is 5. And so I wanted the denominators to be the same, and they are. And now all I have to do is subtract the numerators. So 1 square root of 5, add, plus 5 square roots of 5 is 6 square roots of 5 all over 5. And then the 5 and the 6 don't reduce with one another, so I'm done. So now we're going to do number 25. Do that on this paper here. I'm like, how many problems again are there? Square root of 2 times 5 square roots of 3 plus 4 square roots of 2. When I distribute those, I'm going to get 5 square roots of 6, right? Because 2 times 3 is 6. And then these multiply together, and I get plus 4. And then I get the square root of 4, right? 2 times 2 is 4, but the square root of 4 is 2. And so this is 5 square roots of 6 plus 4 times 2, which is 5 square roots of 6 plus 8. And these are not like terms. This has square root of 6, and this is just a number, so that's all that can be done there on number 25. You might write it, maybe like if this problem was in your book, it probably was in your book. They probably wrote it like this, and both are good. Okay, and then 26. So 26 looks like this one. They are conjugates here, so I don't have to multiply the whole thing. So they are conjugates. I can just, when I FOIL, I can just do the outer, the first and the last. The outer and the inner make 0. So here I'm going to get x, and here I'm going to get minus 16. And that's it for 26. And then 27, so I have 5 times the square root of 24 x to the 10 y to the 8 times 2 times the square root of 18 x to the 7 y to the 4. And there's choices of how you could do it. And so your choice on how you go. What multiplies together are the 5 and the 2, and that makes 10. And then what multiplies together is the stuff underneath. And so 24 times 18, just let me write it like that for a second. And x to the 10 times x to the 7th, just let me write it like that for a second. And y to the 8th times y to the 4th, right? And 24, so 5 times 2 is 10. I don't want to multiply 24 and 18 together, which I certainly could, because how do I take the square root of that? By prime factoring. And so this is already, if I multiplied it together and got a really big number, then I prime factored it, it would be the same. But 24, I could actually prime factor in my head. It's 2 times 12, which is 2 times 6, which is 2 times 3. And 18, I can prime factor in my head. That's 2 times 9, which is 3 times 3, right? And there's 17 altogether x's. And if I want to put them in groups of 2, I'm going to put 16 of them together, and one more makes 17. And then the y's, I'll put them all together, y to the 12th. It just has to be even. So now I'm going to start circling in groups of 2. So a 2 will come out and be with the 10. Another 2 will come out, I know they're not right next to one another, and be with the 10. Okay, so these are out, right? And then a 3 will come out and be with a 10, and a 3 will be stuck underneath. And then 8 X's will come out and be with the rest of the stuff, and 6 Y's. And stuck underneath is a 3 and an X. So that all together, we're going to get 20, and 20 times 6 is 120, is that right? X to the 8th, Y to the 6th, and then the square root of 3x. Okay, and that was number 27, and that was the last one in that little section. Okay, and then, so I'm going to put these on a different piece of paper. So we have all these problems here. So this is on this paper, the review sheet. This is 28, and I got a square root. They're asking me to check 2x plus 10 plus 3 equals 5. You have to get your radical by itself, so I'm going to take away 3. When it's a square root, I pause and I look at what I have. I was going to put 8, but it's 2, sorry. If this is positive, then you go on. If it's a variable, you go on and you check. If it's negative, there's no solution, right? So this is what I'm looking at right there, the 2. And so because it's positive, I go on, and how I go on is I square both sides. So I get 2x plus 10 equals 4, and I take away 10. I get 2x equals 4 take away 10 is negative 6, so I get x is negative 3. And then you should always check on these. So I'm thinking that because it was positive there, that it should be okay. So I'm just going to make sure though, so I'm going to check. So it's a good idea to always check. And so if it's a variable on the other side, which 2 is not a variable, then it's a must check. And you check in the original equation. So 2x plus 10, so x is negative 3, plus 10 plus 3 equals 5. So this is me checking my work. So this is the square root of 4 plus 3 equals 5. Square root of 4 is 2 plus 3 equals 5, and certainly it worked. Okay. So, and then number 29, so 29 looks like this. This is a plus. And the radical is already, the square root's already isolated. So you look at what you have here. And if it's a positive number, then you just go on and smiley face. It'll work out. If it's a variable, then it'll work out, but you have to check. And if it's a negative number, now I'm looking at this whole thing. Is it a negative number? No, it's not a negative number. It's got a variable, right? I don't know what x is. And so I don't know what x minus 2 is. And that's what makes it a variable. So I know I have to check. So I am going to square both sides. I'm going to, so that I have my original still there. So I'm going to square both sides right here. So when you square a square root, you just get the radicand, which is x plus 10 in this case. And over here, you have to write it twice and use FOIL. So this is x squared minus 2x plus 4. And so this is x squared minus 4x plus 4. So these are old friends, right? And so this is something I know how to solve. It's my pal, it's my friend, it's my quadratic, right? So I'm getting 0 on one side. I'm hoping it'll factor. If it won't factor, I'll use the quadratic formula. And to make 6 is 1 and 6 if I want it to subtract to be 5. So this is x minus 6, x plus 1 to make negative 5. So when I set the pieces to 0, I get x is 6, and I get x is negative 1. And remember that I was on check. And so these are possible solutions, but they might not work. So I had a must check. So here's my original problem. So when I put in 6, I have the square root of 6 plus 10 equals 6 minus 2. See how this now, I know this is a positive number. So this one's going to work. Remember, a positive number on that side would work. And I had x minus 2. I didn't know what x is. Now you tell me x is 6. I know it's a positive number. And you see that it does, because the square root of 16 does equal 4. Whereas the other one, when I check it, x plus 10 equals x minus 2, and I put in x is negative 1 in both of these spots, now I see, oh, this was a negative number. So this is not going to work, right? Negative number is doesn't work. No solution, right, from that. I already have one solution. My one solution is x is 6, but x is negative 1 is not a solution because the square root of 9 is not equal to negative 3. That's not true. So this is not a solution. So this is my solution, x is 6. Okay, so we did a lovely job on 28 and 29. Man, those were more work than the ones on the first page, huh? And took more room too. So now I'm on number 30. Number 30 is the cube root of 2x plus 7 equals negative 2. Now, you might be saying, oh, it's a negative, so it's no solution. But that's only if it was a square root. So if you have a square root equals a negative, then you can be done. But if you have a cube root, well, cube roots can equal a negative. And so when you have a cube root, this is all okay. Whatever I have over here, it's going to work out. So it doesn't matter on a cube root. So you just cube both sides. So this is 2x plus 7 equals negative 2 raised to the third is negative 8. So I'll take away 7 because now it's my linear person to solve. And I'm going to get negative 15 over 2. And I suspect that it will work unless I have made a mistake. And so it's not mandatory that I check this. It won't ever have an extraneous solution, but it's just a good idea to always check whenever you solve, because all you'd have to do is make a tiny boo-boo and then you'd say, I don't have the right answer. So this is the cube root of negative 8, right? Negative 15 plus 7 is negative 8, and that does equal negative 2. So negative 2 equals negative 2. Remember, the cube root of a negative equals a negative. So now I'm on 31. And I have 2x plus 7, it's a square root though, equals negative 2. And this is one where a square root equals a negative. I can just tell you that's no solution. So when I pause and I look, is this negative? Is this positive? Is this a variable? A negative number, a positive number, or a variable? It's not a variable. It's not a positive number. It's a negative number, so it's no solution when it's a square root. So this is number 32. And I have raised to the 1/3, 11x plus 6 raised to the 1/3 plus 3 equals 0. And that's the same as the cube root. So if it makes you happier to write the cube root, go ahead and write the cube root. And how you solve problems that have roots in them is you isolate the radical. So I need to subtract the 3 to the other side. And then raise both sides to the third root, and there's not to the third, and there's not any problems on a cube root, right? And so I'm just going to raise this both sides to the third, and there won't be any issues. It should work unless I make a mistake. And so if I made a mistake, then of course it wouldn't work, right? Like if I said to you guys, this is -9, and then when I went to check it, it wouldn't work because this is not -9, this is -27. And so if you, as long as you don't make any mistake, it'll work, right? And so anyway, and so this is going to be whatever 27 plus 6 is. So this is 11x equals -33. So x equals -3, right? If I divide by 11. And then when I check it, so I'm going to have 11, and then I'm going to check here, -3 plus 6 raised to the 1/3, right? I like to check in the original plus 3 because if I don't check in the original, I could have made a mistake at the first, in my first line. So this is 11 times -3 plus 6 raised to the 1/3. Now 1/3 is 1 divided by 3. So I can write it like that, 1 divided by 3, or I can write it, oh, this calculator won't do that like that, so I have to back up there, back up one more, put the fraction thingy, and then or I can write it like this, 1 divided by 3. My choice on that, and so plus 3. And I get 0. And so I did this part on my calculator, and it worked, right? 0 equals 0. So we did a lovely job on that. I expected that it would work. And 33. Oh, 33 is going to take more room than that. Oh my gosh, I injured my finger. That's all I can think about. You ever get a paper cut on your finger? And I mean, it's like crazy. So this is a square root. And I'm going to need to square both sides. So I have 2 square roots, and I can't get them both isolated at the same time. So I'm going to square both sides here. And I hear somebody in my family I need to go help, so I think I'm going to make this in 2 videos. I wonder if I can get this problem solved, though. So I don't think I can. So this is here. Right, FOIL this out. 1 plus the square root of x. Nope, I gotta go.